Hello everyone, and welcome to Careers in STEM series. My name is Akul Gunakula, and I'm a sophomore at Troy High School.
Hi everyone, my name is Tanisha Panchal and I'm a junior at Troy High School.
We are FRC Team 226 Hammerheads from Troy, Michigan, consisting of over 100 high school students from Troy and Athens High School.
We've been competing in the first robotics competition since 1999. This Career in STEM series is a bi-monthly show occurring on the first and third Thursdays of every month. During these episodes, we interview an individual working in the STEM field and learn about their experiences. Before we start, remember to put any questions you have in the chat and we'll answer them at the end.
Today we have Haley Dalzell. Haley is a Troy High School graduate from 2010 and studied at Carnegie Mellon University, where she got a bachelor's and master's in electrical and computer engineering. She stays involved in FIRST by mentoring FRC Team 3322 Eagle Imperium in Ann Arbor, Michigan. For this series, we will have a 30-minute interview period, and we will be answering questions from the chat periodically throughout the interview. So Haley, can you just tell us a little bit more about yourself?
Yep, so I think you said a lot of it in my introduction. I was on the Hammerheads for 4 years and went off to school and got my bachelor's and master's in electrical and computer engineering, and now I work for General Motors on level 2 autonomous vehicles, so cruise control with steering control.
So you mentioned about your first robotics experience in high school. Can you tell us what other activities you were part of in high school and how did they help you prepare for college?
The only other activity I think I took part in high school was I was in the Japanese club since I was taking the language classes. That was mostly a social activity, of course. In my senior year, though, I was president of the club, which I think gave some good leadership experience and organizational, figuring out how to plan things and meetings. When I was on the robotics team, I didn't take part in the organizational side of things. I mostly worked on the robot the last couple of years, so that was a good experience.
So when you say you worked on a robot, did you do like programming, fabrication, design?
Yep. So my first 2 years on the team, so back when I was working on the team, only so many students could work on the robot because we were building our robot out of the Warren Tech Center of GM, General Motors Warren Tech Center, with our mentors there. But you could only have so many students in the building at a time, just because of the number of adults that were there. So because of that, usually only juniors and sophomores would be working on building and fabricating the robot. So my first 2 years on the team, I helped out with the chairman's award and volunteering and planning type things like ordering t-shirts and t-shirt design and things like that. And then my junior and senior year, I was able to go work on the robot, and most of what I did was actually fabrication of parts and assembling the robot, trying to find issues and solve mechanical problems where the robot wasn't doing what it's supposed to do.
What was your favorite part about being on Team 226?
My favorite part? I think really the best part was that I remember was being with all my friends and getting to do a nerdy activity together. I really felt like I was with my people, that I got to do something I enjoyed with all of my friends. And of course, I really enjoyed learning from our mentors how to build the robot and learn things that I would have never learned in school or on my own, like using machine shop tools, and learning from them was a really good experience.
So in high school, what APs did you take, and what would you recommend for people like in your field specifically to take as well?
Yep, I took Calculus AB and Physics C. Those are the only two I took, which was a little bit less than some of my peers at the time, probably even less now than you guys are taking. I would definitely recommend Physics C, especially because of the electromagnetics portion. Physics 2 in college tends to be a notoriously difficult weeder course. So if you can get it out of the way in high school, even though Physics C can be difficult in high school, it's even harder in college. At least it was where I was. And a lot of my friends were really jealous that I got to skip out of Physics C. So I definitely recommend that. And of course, calculus, that gets you just a little further ahead if you don't have to take it while you're in school or in college. So there, I don't have any other good recommendations since those are the only ones I took, but those were definitely great choices. I think calculus BC, I wish I would have taken in high school. Those are still the names, right?
Okay. How do you think these APs helped you with your field in college and even your major?
Really, I think the biggest thing the APs help with is getting you a little bit further ahead in classes. It's just every AP you take is one less class that you need to take in college, especially if it aligns with your major. If you can take the APs and get those classes out of the way, then you can have a lower course load some semesters where you're only taking 3 classes instead of 4, or you might be able to take more advanced classes instead in a subject that you're really interested in. So you can really get more out of your class time and semester because you're just that further step ahead. And a lot of students, because they came in with so many AP classes, they were essentially a semester ahead and they were able to graduate a semester early. And some students, because of this, Carnegie Mellon had a 5th-year master's program where you can, if you have good enough grades in undergrad, you can get in almost automatically without taking the GRE or anything. They already know you're a good student. They've already accepted you once. They're going to accept you again. And I think a lot of schools have a similar program. So what students were able to do, because they were so far ahead on their APs, is that this 5th-year master's program, they were able to start it in their 4th year of undergrad. And then they only had 1 semester left when they finished their bachelor's degree, 1 more semester, and they have their master's done too. So they were able to skip ahead. I didn't do that. I took a full year to do my master's, but that's still faster than many people who take 2 years to do. So definitely APs just help you finish faster and make things easier or more interesting later on.
So in high school, obviously there were many interests. Did you find that your interests from high school changed when you went to college, or were they relatively the same still?
I think a little bit of both. My interest in robotics stayed the same. But when I went into college, I thought that I was going to do mechanical engineering because of my experience in fabrication and design on 226. I thought I wanted to be a mechanical engineer. But during my freshman year of college, I had to take 2 intro engineering classes. So I took mechanical engineering and I decided to take electrical and computer engineering. And I liked electrical computer engineering way better. Just me personally, that's what I was way more excited about that class, and I decided to not switch majors since we didn't decide till the end of our freshman year, but I decided that I changed my mind from what I thought I was going to do at the beginning to a different major. But my interest in robotics definitely stuck around. I wanted to continue doing that for my job in the future and career.
So just before we move on to talking more about your college experience and your major, I think you mentioned something about GRE. Can you talk a little bit more about what that is?
Yeah, it's an exam, you can kind of think of it as similar to your SAT or ACT test that you're taking before you enter college. It's a test that you take prior to grad school, and you submit the test scores as part of your application to grad school. I didn't have to take it though, since my application to my own school didn't require it.
So you talked about mechanical engineering and electrical and computer engineering. So can you tell us what each of those are and what the differences are?
Yeah. So mechanical engineering is going to involve design or testing or requirements definition of mechanical systems or parts. So that could be anything from thermodynamics in how, and this isn't my field, so I'm gonna do my best. But this could be anything from how materials or fluids move through an engine, for example, gasoline moving through your engine to power your vehicle, how the heat affects things, how the heat transfer affects things, to how the structure of materials and the forces that are acting on them to make sure that the part that you're designing can withstand the forces it expects to be placed under. things like that.
So a lot of physics.
Yeah, all the mechanical side of physics. Whereas electrical and computer engineering is more of the side of electrical components, and this can be anything from hardware design, so designing circuitry like that goes in your smartphone, to your microwave. And it can be also not just designing that circuitry, but also programming it. So this can be software for your computer. A lot of my peers in electrical computer engineering stuck to the more software side of things and were almost very close to being a computer science major, where they were working on software for different tech companies to do with their online workplaces or shopping websites for managing both the back and the front end of the website with the database that's managing how much of the items are in stock, things like that, and then the user interface for people to actually purchase things, all the way to some of both hardware and software design for trading stocks in the stock market. Financial institutions want to trade stocks as fast as they can and make financial transactions as fast as they can to make their money. So there are jobs available in those areas. You wouldn't normally think the financial sector would have electrical and computer engineering jobs in it, but it definitely does. And so there's those things, anything from antenna design for communications equipment to embedded software, which is what I work on. So this can be anything from, as compared to software on your computer, like Microsoft Word or other things that a consumer uses on their computer, software that they install. There's also software in a lot of the things you use every day, like your microwave or an elevator or your car and making the windshield wipers turn on and off when you flip the switch. All of that has computers in it, and somebody's writing the software to say the elevator needs to go to this floor at this speed and not miss the floor or stop in the middle when you press the button. Everything needs to communicate, and in a vehicle there's lots of computers. There's a computer to control the brakes for the new automatic braking systems, which is different than the computer controlling the windshields or the tail lights. All of those computers have to communicate together in what we call a distributed embedded system. So that's what I work on, is just software for one of the modules in a vehicle.
So obviously this field of work is really complicated. What got you into this field of work? Was robotics a major contributor to that, or was there anything else?
Yeah, definitely. So when I started at Carnegie Mellon, I was very interested in robotics, of course, having been on the high school robotics team. So I looked up the robotics minor and looked at what are the courses I need to take for the robotics minor. And one of the courses was embedded software, which is a lot of what I described, and then also controls, which is using software to control something mechanical. So imagine a robot arm in a factory. It's the arm itself is a mechanical thing, but you need to tell each of those joints in the arm when to move and how to pick up the part and place it somewhere. So that's controls, and that can go anything from controlling how the power in a microwave when you turn it on, the low setting and the high setting, all the way to the robotic arm or controlling an autonomous vehicle. So embedded software and controls kind of go hand in hand, and those are both on the requirements list for the minor. So I decided to take them, and I realized I really like that, and that was the reason I liked robotics, was because I like writing software to see something physical move, as opposed to writing software to see an app on a screen do something, which is cool in its own way, but not what got me excited personally.
So you said that robotics was obviously a big factor, but mechanical engineering, it's not something like I personally have never heard of, like a lot of these like degrees. So how did you find out about like mechanical engineering and then electrical and computer engineering?
Gotcha. Yeah, I think I learned more about the different degrees just by when I started my college search, looking around at the different colleges and what degrees they had in their College of Engineering, because I kind of knew, well, I like robotics, engineering is what probably the best fit for me. And I looked at the options and mostly kind of Googled or asked my parents or friends, what are these different majors? What's the differences between them? And so beyond mechanical and electrical, there's things like civil engineering for designing structures of buildings or roads or infrastructure. There's chemical engineering, which is the chemical processes of manufacturing things. Or so there's more to it than that, that I don't know about. They get very specific once you go to college and pick your major. You learn a lot about yours and less about everyone else's.
Can you tell us a little bit more about what kind of organizations you were involved in college, or any activities that you did?
Yeah. So the first club that I decided to join was one completely non-academic because I wanted a break from my schoolwork. So I joined the origami club. I had done origami ever since I was in elementary school, and I was amazed that there was a club just for that in college. So I decided to join it, and that was a good opportunity to take a break from classes. I think it's very important to, once you get to college, it can be really easy to drown yourself in work because it's a lot more work than high school. And I think it's really important to give yourself structured time to be social and relax so that when you go get refreshed, and this was the perfect club for that. Activity that was so the soapbox cars that they're building, they build out of a pod out of carbon fiber that a very small girl usually gets inside of and steers as it rolls down the hill. And then at the bottom of the hill, there are runners who are using this cart as a baton almost to push it up the hill and pass it to the next person who continues to push it up the hill, passing it to the next person to cross the finish line. Very silly, doesn't make sense to anyone who hasn't been to the school, but it's a lot of fun. Another, again, social activity, but is a little more active. I participated in building one of the buggies on one of the teams. Met a lot of good friends that way that I'm still friends with today. I also participated in the robotics club. That was another good activity. It wasn't competitive like First Robotics is. So some schools have competition robotics teams. This robotics club at the time didn't have any competitions that participated in it. It was more hobby projects and ideas that students had. The club had the resources to build almost anything you wanted. We had 3D printers before they were out in a lot of other places, and a whole machine shop, so you could do almost whatever you wanted. The first project I joined was a project building an office chair on tank treads, so you could drive the tank chair around. I didn't work on that project for too long before a friend and I came up with an idea to make an autonomous buggy that drove itself. Since we were both interested in the robotics and autonomous vehicles, we thought building a self-driving buggy would be a great way to combine buggy with robotics club. So we started our own autonomous buggy group and worked on that.
So in the buggy club, when you say that you created it, how did you go about it? Is it very similar to like how we create a robot in FRC, or did you find that you're using new techniques and like new ideas in there, in a sense?
I definitely say it's new ideas and techniques, but also a bit of both. A bit of both. So we were working with carbon fiber, which most FRC teams aren't working with. So that involves making a mold that you need to press the carbon fiber into and find ways to reinforce it so that it's rigid and able to protect the driver.
Yeah.
So there were some new techniques and things I hadn't learned before, but then also similar manufacturing to make the steering. I would say that buggy itself isn't the most engineering oriented people like building a buggy, but it's not the most advanced engineering club. It's more combining a social activity with engineering than an engineering club. A great engineering club, if you want to really hone your engineering skills, would be Formula SAE is one of them. I think there's a lot more similar projects like that at other schools, but that was, I know, a huge one that people got into with design challenges and judging competitions and working on their electric racing vehicle. So.
Can you talk a little bit more about the Formula SAE thing?
Yeah, so I didn't participate in the team, but I knew some people on it. Formula SAE has multiple different divisions of competitions. There's gasoline racing, there's electric racing, and I think some others, where students work together to design and build an entire vehicle to race in a Formula SAE race every year. And at these competitions, there's also design competition where you present your design and all the design decisions you made to judges, and they evaluate your design. That's about all I know about it since I didn't participate, but I do remember that the Formula SAE students were highly sought after by the recruiters. If they saw Formula SAE, they knew the student was serious because it was really good hands-on experience, similar to how FRC is great hands-on experience in high school.
So, did you do any research or internships in high school or college?
So I did research for one semester in college. I mostly did it to try to figure out if I enjoyed doing research, and I found out that I didn't. I'm definitely someone who prefers to work under a structure that's already there or already predefined goal of like the company is working on this, we need to have this deliverable and figure out how to work on it together, whereas research can be more open-ended, which I found for me personally was less motivating. But I also did have internships every summer, even right after graduating before I started college. My first internship was as a civilian, not in the US Army, for TARDEC. It was called the Tank Automotive Research and Development Command, I think. That was in Warren, nearby. I found out about it because my mom worked in the same complex. She heard about the internship and said, Haley, you should apply to this. They're taking high schoolers. So I applied online and I ended up getting the internship. And then I went back to intern there the next 2 summers after that. So those second 2 summers, I was working in the robotics lab. One of them was on an autonomous vehicle simulation software. I was running some tests and learning how to use the software and things like that. I don't know how much I can say about it. And the next summer, I was working on a path planning algorithm for a robot to explore an open space in a room or something to try to navigate the room so that they could send a robot in instead of a person. After that, I applied to an internship at GM, General Motors, and I ended up in the active safety department, which is where I still work today. I liked it enough, I stuck around. So during that internship, I got to ride in the test vehicles and do testing and look at log data, try to understand when the vehicle was not in the center of the lane and characterize how far out of the center of the lane it was so that we could figure out if our software changes were improving or not improving the performance. And I also got to ride in the test vehicles the next summer a lot more and tune the control algorithm that kept it in the center of the lane. So using PID, I don't know if that sounds familiar if you work on the software for the robot, but the programmers might be using that on the FRC robots. So what the programming team is doing potentially with PID on robots, many teams use it, is applicable to a lot of internships as well.
How did you find these internships? Was it just going through like career fairs, or was there something specific that you did?
Yeah, so my internships, my first one I found out about, of course, from my mom. She let me know about it and I applied. That one was easy. I didn't even have to go searching. Once I got to school, and once I got to Carnegie Mellon, I would go to the career fairs and talk to the recruiters and apply for postings. A lot of them you need to apply online, and that's even more true now. So I applied to a lot of postings there, had some interviews, but this particular, the GM internship, I happened to get a little lucky where my mom had been said, hey, give me your resume so I can share it with my friend who works at GM. They say they're looking for someone, and I ended up getting an interview. That is not normal. That's not a typical way that happens. I think that was very lucky. Most of the time when people are looking for jobs and internships, they're going to the career fair and applying online. And I now I'm young career fairs, and now I'm one of the recruiters looking for students to interview or ask them to apply. And now it's almost all online applications, especially with all the things that are going on right now. You can't interview people in person. So a lot of the best place to look is online. And I would definitely recommend keeping an open mind and looking into the different companies at the career fair, because I think one of the things that students tend to do is they look at companies they know first. Like they see Google and they're like, I know Google, they're awesome, I want to go work for them, let me go talk to them, which is great. But there's plenty of other companies at the career fair who have jobs open that might not have as many people applying because people don't know who they are. And it's really easy to pass those companies up because you don't know anything about them. But I definitely recommend talking to companies that you just walking up to a booth even and saying, hey, I'd like to learn more about you, is a great way to learn what that company does and learn if it would be interesting to you, to see if it aligns with the type of job you're looking for. And then there's also a lot of opportunities there for them to say, hey, this person's great who came and actually talked to us. You can find a lot of companies flying under the radar that way that are actually very good companies to work for.
So you're a college recruiter now. So what do you look for in a student if you want to choose them to be interviewed and things like that? What do you look for?
The biggest thing I would say is whether the skills and courses they're taking match the positions we have open. So if we are looking for engineers, we're looking for students who are interested in, specifically for GM, embedded software and controls classes. Because those are the type of electrical engineering jobs we tend to have. Once in a while, we're looking for students with the major for the job we're looking for and who are interested in taking the classes that would match that job. So and similarly with mechanical engineering, are they taking courses that relate to things that we do at General Motors? So that's the first thing. Just are the things that you're interested in match the positions that we have? So with that being the first filter, don't just get discouraged if you don't get an interview, because sometimes it's just what you're interested in wasn't what they had open. So never take that personally. The second thing that we look for is just general interest in what we're doing. So beyond just, are you taking classes that match what we're looking for? Are your extracurriculars or things that you like to do related? When someone says they like to work on cars, they've worked on cars since forever, that's usually something that we like to hear. Being a car company, people who like to work on cars usually want to come to GM and they want to stay at GM. People who are interested in robotics or are interested in the engineering work that we do, if they're passionate about it, that's the next thing. And beyond that, generally, we do want to make sure that the students that we're interviewing are actually interested in coming to Michigan. We ask questions like, how do you feel about Michigan? And if they say, oh yeah, I like Michigan. I am in that area. I grew up in Ohio, so it's, nice to be close to home. That's great. But if they're saying, I don't know, my family's in Texas, I don't know if I'd really be okay with Michigan, we may still interview them if we think they're a really good candidate. But if they're not interested in coming to Michigan, if they're not going to take the job, we might not interview them. So based on their interest. And of course, some people say, well, I'm okay with anywhere, and that's great too. So we're really trying to figure out, does the candidate match the job, and do we think they want to work for GM? Do we think they're interested in what they're going to do, what they would be doing here? Do we think they'll stay?
So staying and giving them a job after their internship is pretty crucial for you guys then.
Yeah, when we interview people and have them come for an internship, we want them to stay full time. It's kind of a test drive for both parties, for the student to get to know GM, to understand what it's like to work there, and for us to get to know them and see if they're a good fit for the team. Usually, it is a good match with the internship, and the interview process for that is usually pretty good indication that the person would want to work at GM. But yeah, internships very often, especially later on when you're a junior or senior in college, internships are definitely geared towards they want you to come back full time.
Okay.
What kind of professional opportunities or jobs are available to someone with your major?
Yeah, so I think I talked about a few of those earlier, like in the financial industry and different software and hardware for financial trading, or I have friends who work on chip design for different companies out in California or elsewhere, working on the hardware for smartphones or communications, storage for data. And then specifically like what I did, embedded software and controls is great for getting into any sort of consumer electronic devices that aren't at the compute level of a smartphone, but are still complicated systems because it's many computers communicating with each other.
Yeah. So you got your master's immediately after your bachelor's, and because Carnegie Mellon was offering it, do you see that there's a distinct advantage to getting a master's right after your bachelor's, or is it not matter as much?
I think that there are definitely pros and cons. If you get your master's right after, it's out of the way. You don't have to worry about going back to school. You're done. You get a pay bump. As soon as you get out, you don't have to think about it. It's a very straightforward, I don't want to say easy because it's still a lot of work, but you're front loading that work to doing it sooner rather than later. A lot of people want to go back to school and get their master's. But the benefit of waiting is that you may find that, like one of my friends was mechanical engineering. And after about 5 years, 6 years working as a mechanical engineer, he decided, you know what, I'm getting kind of bored. I want to do something else. So now he's going back to school to get his master's in electrical and computer engineering so he can switch career tracks. So sometimes if you find after you've been working for a while, there's this thing I would really like to learn more about that I haven't had an opportunity to learn, you can go back to school and take classes in that area and find a new job in a different career path. If you take your master's sooner and you want to switch later, it might be harder, or you might be getting a second master's, or you might not absorb it as much in the first master's if you are taking classes that later aren't relevant. When you do your master's later, you can kind of target a different area of learning because now you've been working for a while and you know what you want to learn. So the next big benefit is that a lot of companies will pay for you to get your master's, usually in exchange for you working for that company for a certain number of years. They don't want you to just take their money and then run as soon as you're done. So there's pros and cons. I'm glad I got it out of the way. That I'm glad I did it right away because those classes were directly relevant to my job and have helped me get ahead sooner. But it's really up to you. I wouldn't push yourself to do it because you think it's the right thing to do. It's only if you already want to do it, because you might want to leave that opportunity to do it later too. So, and have them pay for it.
Can you tell us a little bit more about your job at GM? What does a typical day look like for you?
Yeah, so a typical day for me has changed over the years. When I first started, I would be spending a couple days at my computer, working in occasional meetings with people sitting near me, talking about software changes we need to make and coming up with a design and planning on whiteboards, and then doing the work and writing the software and test cases. And then we would take our software and actually put it into a test vehicle and get to go drive it around and collect log data and try to understand why certain things weren't working or not as well as we thought. we take that log data back to our computers, look at it, and try to analyze it and figure out what happened, what are the bugs, what are the things we could improve, and then repeating that cycle over and over and over again until the software is ready to be put into the vehicles that are in production and sold to customers.
So you're an embedded software engineer, right? So what exactly is that, and how does it compare to a software developer?
Yeah, so software development, embedded software engineer is still software development, just specifically for embedded computing. So embedded computing is different than like your laptop in that it's computers embedded in devices like your microwave or in a vehicle. It's computers that you might not even realize are there in a lot of cases. And usually the processors and the compute power of those devices is a lot less than your computer at home or a server somewhere. You don't need a lot of high-powered computing to tell a wiper blade when to turn on and off. Maybe it's a little more if you have like rain sensing and you want to make it turn on and off automatically, but it's still not as much as your computer needs. But all of those computers in the vehicle need to communicate. And so working on the communications and making sure that you're sending data that's important from your computer to somebody else's computer in the vehicle. There's all different teams working on this. So my department at GM is just working on one module in the vehicle that's using the radar and the camera data and the GPS to look at vehicles around it on the road to try to speed up and slow down with traffic or to prevent an accident or try to steer the vehicle when cruise control's on, all the way to my friend who works on the brake control module. So when we say, oh no, there's a vehicle ahead of us that's stopped, and if we keep it at our current speed, we're gonna hit them, we need to apply the brakes. We say, hey, brake control module, hit the brakes, and then they write the software of how heavy to apply the brakes, and if they get multiple requests, who do they listen to? And that he works at an entirely different company at a supplier. So there's multiple companies working on all these different computing modules in the car to have them all work together. So embedded software really deals with both the communications and coordination between all the different computers in the vehicle, and then also controlling the actual physical vehicle of how to apply the brakes and how hard, things like that.
So what programming language do you use on like a daily basis?
I use C. A lot of my peers use something called Simulink, which is part of a tool called MATLAB, Matrix Laboratory. Most college students learn how to use MATLAB. It's pretty big no matter what engineering major you are. But I know that other companies will use C++ or depending on what the use is. I think C is pretty common in embedded software, but C++ is definitely growing.
Were there any challenges or difficulties you had to overcome as a girl pursuing a career in STEM?
I would say very luckily for me at GM, I've been very lucky to have a wonderful team to work with where I haven't experienced any situations where I felt like I was being treated unfairly. I do have friends who felt like they weren't being taken seriously or that their team didn't believe that they could do a good job or that they should just work on the easy stuff and let other people work on the hard stuff. So there's definitely sometimes that I won't say that doesn't exist still in the industry. And sometimes you can feel like you need to prove yourself because you're afraid that if you try something new and you fail at it, you will just be proving everyone right that a girl maybe can't do something as well as a guy can. And that makes you not try something, and it becomes a self-fulfilling prophecy that, well, yeah, you won't be able to do it because you didn't even try now. Forget whether you couldn't after you tried. Now you won't be able to because you didn't try at all. So if I had any advice that I would give to women who are interested in STEM or want to try to learn something new on their robotics team is don't be afraid to try, and it's okay to fail. If you don't try at all, that's like you worse than trying and failing. Don't hold yourself back because you're afraid to prove a stereotype right. Definitely do your best.
How did you go about job interviews and salary negotiation at GM?
Yeah, so job interviews in general, different companies will do different ways. Some will do what they call, especially for, maybe, and some of this advice might be specific to electrical and computer or software engineering. Some companies will do what we call technical interview, where they'll give you a usually straightforward or simple programming problem and ask you to solve it or write a solution on a whiteboard or in advance and submit it to them so that they can see your coding style and generally just how familiar you are with programming. Sometimes there's a simple question that if you've been practicing programming for a year, taking your classes, you'll do just fine. Some are more complicated and they want to see how you think and whether you know something specific about the programming language they use, because they want someone who's really an expert at that language or something like that. Those questions to prepare for, there's actually a lot of good online resources for preparing for programming questions that give you practice problems that someone might use in an interview or similar to them to just get you thinking in that mindset. So if you're looking for some sort of, and this applies to computer science majors as well, any sort of technical interview for programming, that's definitely a good thing to do, is look at those online practice problems and get familiar with them. And then there's behavioral interviews, and you might have a mix of both in multiple interviews if you're interviewing with a company. And behavioral is asking more questions about can you tell me about a situation where you had to work with someone who was difficult and you had to resolve a problem with them so that you could get your project done on time. And this is more to see what your personality is like and to see if you're someone who works well with others. To just kind of weed out people who are like, I work by myself and I don't like anyone else, and things like that. And some interviews will be both of those. Usually an interviewer will tell you what type of interview it is beforehand, and if they don't, you can always ask. So my experience interviewing has been, at GM, I've had more of the behavioral interviews. And again, you can look up behavioral interview questions online to prepare and just kind of get some thoughts moving ahead of time. I think the biggest thing before an interview is to just prepare so that you feel calm and comfortable. Because if you're stressed out, you won't do as well. It's as simple as that. No matter how good your skills are, it might not show if you're really nervous. So do whatever you can to practice. Even with a friend or the Career Center can do mock interviews to help you just get used to it so you feel comfortable. As far as salary negotiation, I didn't need to do much negotiating. When my offer first came back for when I finished my master's degree, it was the exact same offer as when I had finished my bachelor's degree, and they didn't know I was going back to do my master's yet. And so I did need to talk to them and say, hey, I was expecting a little more now that I have a master's, and it turned out to be some HR mistake or something. I don't quite remember, but don't be afraid to very politely say, hey, this is very nice, I appreciate the offer, but this is what I was expecting. Mm-hmm. And I think the best thing is to just be polite and humble about it so that, yeah.
So you're still a mentor in the FIRST community. How do you find that FRC specifically as well has changed from when you did it to now when you mentor it?
Oh, the biggest thing is the number of teams. It's crazy. Back when I was in FRC, the number of competitions, we only had a few regional competitions in Michigan. We weren't even doing the district system until I think my senior year is when the district system started. So there were a lot fewer competitions and a lot fewer teams and a lot fewer girls participating. I see now there's way more girls participating on the teams than there used to be. So that's awesome to see. Just the number of teams and events that was the most amazing thing to come back and see for me. Otherwise, the competitions run similarly. Everyone's still got their mascots and buttons, and some things haven't changed.
How does being involved in the FIRST community as someone from industry compare to when you were a student?
I mean, it's definitely different in that as a student, you're doing the work and excited to compete. Whereas now as a mentor, I'm excited to teach the students things and excited to see them accomplish things and get excited about whatever part of the team that they're involved in. I think for me personally, I'm not the most competitive person. So for me, it's not about losing a competition. It's about how much the students are learning and building their confidence in their skills so that when they go to college, they're ready to go. The other thing that's different for me is being involved as a judge, because I participated as a judge in your Shark Fest competitions for Lego League, and yeah, being a judge and seeing the other side of things and remembering when I was on a Lego League team and how excited and nervous I was in front of those judges, and now as an adult as participating in those things, it's very different.
So, is there any other advice or information you'd like to share with our audience that we haven't already covered?
Not that I can think of.
All right. Well, thank you so much, Haley, for joining us for this interview. And thank you all for joining us today. Remember to subscribe to our YouTube channel.
And make sure to come back on January 21st for our next show with Ian Hart. He graduated from Troy High School in 2011 and is a hardware system engineer at Amazon Zoox. He's received a bachelor's and a master's degree in electrical and computer engineering from Carnegie Mellon. Thank you all for joining. Have a good week.